Hello everyone, let's discuss Codeforces Round 1066 of yesterday. So let's start with the first problem. It is Dungeon Equilibrium. We are given a array and it is called balanced if every integer x that occur at least once occur exactly x times in the array. For example, 1, 4, 2, 4, 4, 4, 2. Here 1 is appearing 1 time, 2 is appearing 2 times, and 4 is appearing 3 times. Alright, but 2 is not a balanced array because the number is 2 but it appears 1 time. Similarly, the 2 to 2 is not a balanced array because number is 2 and it appears 3 times. We are given an array and we want to make it balanced. In one operation, we can delete some of the elements to make it balanced. Alright, we can delete some elements but not add some elements. Alright, so if 2 has occurrence 3 times, then we can make it 2. But if it has occurrence 1 time, then it should be equal to 0. So it should be missing from the array because we cannot add an element and make it 2 right now. So what is our observation? Okay, so we have some number, let's say x, and it appears y times. So what are our possible scenario? If y is greater than equal to x, then it is better to make its occurrence equal to x. Alright, we have two options, either make the number of occurrence equal to 0 or make it equal to x. Alright, now if we make 0, we require more operation. Alright, then making it equal to x. So better equal to x. Alright, now if y is smaller than x, then we cannot add an element. So we need to remove all the occurrence. Alright, so this is our algorithm or observation for this problem. Let's implement it in our code. Alright, so what are we given? We are given value n, which represents the size of our array and the whole array. Alright, what do we want? We want the frequency map. Create a frequency map. Now, what is our answer? Let's iterate over the map now. Alright, if the frequency, okay, element is the first element and frequency is the second element. Alright, now if the frequency is greater than equal to element, what did we say? Add frequency minus element operations. In the else part, what do we add? Just add the frequency itself because all the elements need to be removed. Alright, so at the end, just print the number of operations we applied. Okay, so this is it for the first problem. Let's move to the second problem now. So let's understand this problem with the help of diagram given below. So actually we are currently present inside a grid at cell 0, 0. Now we are given some strings A1, A4 up till AN, which consist of 4 and 8 as characters. What do 4 represent? 4 represent that if, let's say, this is a grid, if you see it, like let me highlight it. If you see, this is a grid. All right. Now, what do 4 represent? 4 represent that after exactly one operation, or let's say after 4 has appeared, this grid would transform to this thing. All right. How did this transformation occur? For each cell, if it's orthogonally adjacent to black cell. All right. These cells inside our current element, this particular element, are represented as black element. And these two neighbors are just adjacent. This particular cell, this particular cell, and this particular cell are just the neighbors of this black portion. All right. So that's why this become blacks now. All right. After 4 has appeared, what happens? This grid become black now. This portion become black. This portion also become black. And this portion also become black. Even this portion become black. All right. Now what happens if 8 appears now? For 8, all the orthogonally and diagonally adjacent element to the black cells become black. So what do this represent? So if you see this particular cell, uh, if you see this particular cell, it is diagonally adjacent to this cell. All right, and this cell is black. So after 8 has appeared, this cell will become black again as well. All right. So what do actually happens in case of 8? Actually, the transformation is like this. All the diagonal elements gets transformed. Like this is the new array now. All right. Even the diagonals and orthogonal elements, both of them gets transformed. All right. So see it through the example given. Like this was the starting element. 1 8 appeared, so it became a square now. Again a 8 appeared. It again becomes a square because 8 is adjacent elements and diagonal elements. And finally again a 8 appear and whole cube is completed. Now in case of string 4848, 1 4 appear and only the diagonal elements are currently filled. If again a 8 appear, then the diagonal elements are filled again as well. Again a 8 appear, then diagonal elements are filled again. Now finally a 4 appeared and you see the pattern. Like this is the pattern, like zigzag type pattern. All right. So you cannot predict where, what is the difference between going upside and going right ways for a particular cell. All right. So can we find a pattern? Finding a pattern would be quite difficult because let's say if two fours are appeared, then if a 4 appears again, then this cell becomes like this. All right. For example, given in this place, the pattern finding is difficult because zigzag patterns appears. So we need to think something different. And okay, what the problem asks us? The problem asks what are the value of or what is the color of coordinates x comma y after all these operations have happened. All right. Like for this example 888, we are asked the coordinates of 3 comma 3, which is highlighted as red. At last it is black, so it is returned as yes. In the second problem we are asked the coordinates of 5 1. Since it is white, so no is returned. All right. So finding the pattern is quite difficult. So can we reverse the problem? All right. How to reverse a problem? Let's say what is happening currently. We are at a cell 0 comma 0 which gets spread out. All right. What if we are at a cell and we go reverse back to origin? If we are able to go back to the origin, then we are sure that this particular cell can be colored as black. What are our observations? Finding pattern is difficult. So reverse the problem. We, what is the reverse problem now? The reverse problem is we are given a cell xy and we want to reach origin from xy using these operations, using reverse of these operations obviously. So let's say we are on a positive cell right now. All right. Let the cell be, okay, let's draw a diagram now. Like this is the grid we are talking about. All right. So here some cells are present. For example, let's say we are considering about this particular cell. Now, let's say this is 0 comma 0. All right. This is the origin. Now, using some patterns, let's say 4848, we want to reach from this cell to this cell. Let's say 8 appears first. All right. Because we are doing the reverse operation. So see the string from reverse. So if 8 appears first, what is the worst possible scenario? Maybe this diagonal element forced this particular cell to become black. All right, this cell gives us the closest representation or closest cell to uh, our origin. All right, because we are at this cell and we saw 8 was the last element. So maybe this cell came from here because these two are adjacent neighbor, and since 8 allows us as diagonal neighbor as well, so this is also a possible scenario. Now what about this particular cell? This is closer, is this closer to origin, or is this particular cell closer to origin, or is it that this particular yellow cell is closer to origin? For sure this yellow cell is closer to origin, so greedily we would like to find, or we would like to reach to the cell closest to origin. Our aim, so shift to the cell which brings us closest. All right. For each character. And at the end, if using this process, if using this process, we can reach origin, our answer will be yes. All right. So let's understand the rest of the part using code itself. So we are given n, which represent the size of string, and x and y, which represents the coordinates. Take a string as input. Now reverse iterate the string. If the character is 8, then we can move to the diagonal neighbor. All right. So first of all, our coordinates can be negative as well. So remember this thing, that reaching 0, comma 0 from this particular cell, all right, this particular cell or this particular cell, that is mirror of this cell. This is 1 2 3 4 above, this is 1 2 3 4 downward. Okay, so reaching the origin from this cell and this cell are equivalent, so just transform this particular cell to first quadrant. So transform our x and y to first quadrant. All right, because length remains same. And we want to reach uh, origin, so it's not good to go in other quadrants other than first quadrant. So if a operation can lead us to a negative direction, we just avoid it. All right. Now what about uh, character is equal to 8? For that scenario, we reach to the cell that takes us closest to origin. All right. If x is farther than y, then transform x, else transform y. All right. At the end, if the value of x and y are 0, that is, we have reached our origin. Just print yes, else just print no. This is it. This is the solution for second problem. Now let's move to the third problem. So let's move to the next problem, which is maximum array 2. In this, we are given three positive integers n, k, and q. Then we are given q tuples c, l, r, where if c is equal to 1, then the minimum of range L to R in our array that we need to design should be equal to k, and if c is equal to 2, then max of subarray L to R in the array that we have designed should be equal to k. Note that k is same for all the ranges which is given initially. Now we need to find the maximum array, any maximum array which satisfies all of these queries. Alright, so what do the problem statement mean? So what is max first of all? Let's say we are given an array like this. Alright, what is max first? Max is the first or smallest element not present in a array. Alright, so if you say that we want to construct a array with max k, alright, then what do we need to do? Array should contain all elements from 0 to k minus 1 and should not contain k. Alright, this is the two conditions required to make the max of an array equal to k. Alright, so now we want to make the max equal to k for some range L to R. Alright, and we need to satisfy one more condition, that is if c equals to 1, then the minimum of this particular subarray is equal to k. If c is equal to 2, then max is equal to k. Alright, we are also given that inputs are generated in such a way that such an array always exists. Now let's observe some things. Let's say we have a range L to R whose max is equal to k. Alright, then any range from L minus x is a positive number, to R plus x, which do not contain k, will also have a the max is equal to k. Alright, why so? Because what was the required condition? That array should contain all the elements from 0 to k minus 1. Since L to R contains all elements from 0 to k minus 1, L minus x to R plus x or L minus x to R plus y can also contain all elements from 0 to k minus 1, because L to R is just a subset of this particular range. Alright, now it should not contain k was the second condition, and we have said that it this particular range also does not contain any k. So this seems fine. So if all the ranges are non-overlapping, alright, what do we do then? First of all, some ranges say that minimum is equal to k. Case 1, minimum equal to 1, or let's say minimum equal to k. So all elements must be greater than the k. Alright, so cannot be used to satisfy this particular condition that L minus R, L to R should contain all the elements from 0 to k minus 1. Alright, because these elements are always greater than k. So it does not contain any element from 0 to k minus 1. Okay, so this is it, and at least one element should be k. Alright, so what do this mean? And in max, we already said that the range does not contain k. So max case 1 range can never be a subset of case 2 range. Alright, because answer is always possible. If this condition is false, then answer is not possible. Now let's derive some things. Let's say we are having two set. The first set all these sets represent indices of our array. Alright, this particular set represent indices which are bound by case 1. These particular set represent indices bound by case 2. Alright, what happens in case 1? Case 1 says that all elements are greater than equal to k. Alright, these are not part of our case 2. So if we fix them equal to k, then it should not be a problem, because for case 1 all elements must be greater than or equal to k. Alright, now what about elements that are part of both case 1 and case 2? Alright, they cannot be k. They cannot be equal to k. Why? Because case 2 says that if k is present in this range, then max can never be equal to k. So these cannot be equal to k, and these should be greater than equal to k. So assign as k plus 1. Alright. Now, if after assigning these two things, answer cannot be gained, answer can never be gained. So it is true in problem, according to the problem statement, that after assigning these two, answer is always possible. Now, for the ranges, our discussion is left for ranges that are part of case 2 but not the part of case 1. Alright, how do we handle this case? What are our observations in this case? One of the observations that we discussed was the subset observation. That is, if L2R has max k, then its superset will also have max k. Now, let's say we are on a number line. Alright. Then we are bounded by some ranges, let's say. Alright. Let's say this is L1, this is R1. Alright. Now let's say this is L2, this is R2. Just forget about uh, minimum of array things because we are only under consideration of case 2. Alright. So just assume that all the elements are consecutive and we want to make the mix of all these elements equal to k. This particular subarray has max is equal to k. This particular subarray has max is equal to k. Alright, what can be a possible scenario? Just start filling from here 0, 1, 2 up till k minus 1. Since answer always exists, this particular range L1 to R1 should always be greater than equal to k. Okay, so we end up at k minus 1 before R1. Alright, here. Now we see that let's say we were at x at L2. Then what do this range? This particular range contain elements from x to k minus 1. Alright. Now what did we discuss? We discussed earlier that if this range has max is equal to k, then its subset also has max is equal to k. Now we see that this is the superset, alright, which has this particular thing as its subset, which has max is equal to k. So for sake of understanding, let's just assume that our point of consideration is this. Now R1 dash is this. This is the place where R got finished. Now we have elements from x to k minus 1 here. Now up till R2, what do we need to fill? We need to fill 1 to, or let's say 0 to x. Alright, because these are the elements missing currently. 0 to x minus 1. Alright, in this particular range. So, so what is the best possible way to fill this? Okay. What is the correct way of filling this? Let's see something. If we are only considering that we are moving to rightwards, alright, then let's say k is equal to 4 for this place. Then if we write such an array, if we pick up any subarray of length n, alright, it contains of all element from 0 to n minus 1. Alright, we picked up a subarray of length 4, then 0 is present, 1 is present, 2 is present, and 3 is present. So for this subarray, max is equal to 4 here. If we picked up this subarray, again max is equal to 4. This subarray, max is equal to 4. So we see that all the subarray to the right of with this construction, all the subarrays of length k to the right of L1 have max is equal to k. Alright. And what did we discussed earlier? We discussed two things, that all subarrays, all queries should have length of k at least. because smaller than that length can never lead to max as k. And second thing, if sub array has max k, then superset also has max k if k is missing from all those elements, and we ensured it with this particular construction of case 1. Alright, so with this construction, we conclude that all the remaining ranges have max is equal to k. So this is our construction that we require. Now let's implement it in a code. Alright, uh, what do we need to do? We need to take input the length of array and k and q. Let's assume that all the elements are -1 initially. Let's take queries as vector of vector as input. Since there are 3 elements, size of 2D vector will be q into 3. Take the queries as input. Now, first of all, what to do? First of all, handle these cases, the subset or let's say common cases with case 1 and case 2, and cases where case 1 is independent. Okay. So for all the elements, let's just find out what are the elements that are part of case 1. Alright, so if t equals to 1, then it is a case 1 type. Then iterate over all the elements. And what to do? Just highlight it. Highlight it by saying that this element is equal to -2 now. Now we have got all the elements that belong to case 2 as -2 now. Now all the elements which belong to case 2 as well. These were the elements that belong to case 1. The elements that belong to case 2 as well and case 1 as well. Case 1 now are represented using -2. And if an element belong to case 2 as well, assign it as k plus 1. Now if it is case 2, iterate over the range. If element already belongs to case 1, then assign it as k plus 1. Now if it just belongs to case 1 and it does not belongs to, if it just belongs to case 2 and does not belong to case 1, then what was the assumption? So if element belongs to case 1, it is denoted by -2 right now. So if a element belongs to case 1 only and not case 2, then assign it as k. Alright. Now about the rest of the part. For the elements that are left over, that is they belong to case 2 and not to case 1, are denoted by -1 now. So just keep on assigning them as 0, 1, 2, and so on. So what is the first element to be assigned? It is 0. Iterate over the ranges. Now if the current element equals to -1, assign it with cur and shift cur cyclically. Alright. Now iterate over the range and just print the vector. This is it. Although the construction is little bit different, so just yes. So this is it. There were some problems related to writing n instead of q, so it's fixed now. And now you can see that the solution is passed all the conditions. Let's understand the first test case. Like for 1 to 3 range, the minimum should be equal to 2. It is equal to 2, 1 to 3 range, and from 2 to 6 range, the max should be equal to 2. From 2 to 6, max is equal to 0, 1, and 2 is missing. So max is equal to 2. So this is the correct solution. So let's move to the next problem. So in this problem, uh, okay, so in the dth problem, we are given a range. Let's say there are 10 to the power 9 players competing, and we want to predict the final score of our favorite player, Goldflex. After analyzing the match, we are sure that his rank is between L to R. Alright, P is the rank of Goldflex. Now there are n offers made in-game bookmarker. The ith offer, the bookmarker suggests an estimation of AI for Goldflex final ranking. That is, the person says that AI's or Goldflex final ranking is equal to AI. Now you need to assume or predict whether his final rank will be smaller than AI or will be greater than AI. If you are successful in predicting, then you win mod of pi minus AI robo coins. Otherwise, you lose these many coins. At the end, for all the possible ranges in of Goldflex position in L2R, we are asked to find the maximum possible score we can guarantee. Note that we are told to find maximum possible score. So, what is the case for maximum possible score? Maximum possible score. Since we are asked about maximum possible score, we assume that we always win. All right. So, okay. So, since we are asked about the maximum possible score, we want that we always win. All right. So, fix a. So, it's our choice. to choose the final rank P such that the final score is maximized. Alright, so if we choose, let's say, a value final rank as P. Alright, so there is a prerequisite for this problem actually, which is a very famous proof during JEE of statistics. You can just memorize this thing even if you don't know the proof, because it is very well known formula used generally in CP. That is the value of variance of a array is maximum about median. All right, that is, if we say we have a number, let's say a1, a2, a3, and so on up till an. Now we want to choose a number which maximizes summation of ai minus a. Let's say a was the number we chose, or x was the number we chose. Then the sum of absolute value of ai minus x should be maximized for whole array. All right. Then this particular number x is said to be the median of our array. You can watch its proof in some YouTube videos, or just memorize this particular thing because it is a well-known fact in competitive programming. Now we see that here as well, if we consider a if we can finally predict a particular p, that is, it is our choice because we want the maximum possible score. So we when will our score be maximized? If we knew the result from starting itself and always bet for benefit. All right, so its problem is reduced to choosing a p of our choice which maximizes our final score. So, and we know that final score, or difference of absolute value, which is what we earn, is maximum about the median of array. So we choose p to be median of the array. All right, now we are also given that p should be in range L to R. All right, so what happens now? And another constraint, p should be between L to R. All right, all right. Let's say this is L. Let's consider all the possible values of p, and this is R. All right, p can be anywhere here, p can be anywhere here, or p can be anywhere here. All right, so if p lies in between L and R, then we can choose this as all right, p always lies in between L and R, and median is here, and median is here. All right, so if the median is in this part or this part, this is our case of consideration, because if median lies in this part, our p also lies in this part. So take, for this particular part, take p to be the median. All right, take P to be the median. What if P lies in this part? Then we need to pick the value closest. Pick the value closest to the median. Alright, then choose this particular value because this is the value closest to our median and is a possible value. So for this portion, pick P to be L. Similarly, for this portion, pick P to be R. And this solves our problem right away. So let's go on and implement this problem in a code. Okay, so we are given our array and L and R. Now we need to sort our array first of all in order to find our median, because median is actually the middle element of our sorted array. Now two conditions: if n is even, if n is even, then uh, median are 2, median 1 and median 2. All right, median is equal to, let's say our n is 6, then 3 and 4, both of these are uh, two contenders for median. All right, this is median 2, but it is simple for the case of odd because median is just the middle element. Let's say our array is of size 5, then third element, which is equal to n plus 1 divided by 2. All right, now let's first solve the case for odd. Now what was the scenario? If median is smaller than L, then let's say P is equal to median initially. Then if median is smaller than L, then P is equal to L. If median is greater than equal to R, even in this case P is equal to R because rest values are not possible. Let's say answer is equal to 0. Now iterate over all the elements and add this value in our answer, like absolute value with this median. Alright, absolute with P. This has solved our problem for all the remaining. See, what is our solved. Now, cases. The median one. Well, all right. What are median and median two? Median one is smaller median, and median two is larger median. All right. So we would want that we can choose any one of them because so both of them gives the same answer. All right. Median one is towards leftward. All right. So it is more probable that it satisfies uh, that it is. All right. Let's understand it using diagram. So this is it. This is median one and this is median two. So now if range is here, L is here and R is here. So if L is greater than M2, it is obviously greater than M1 as well. Similarly, if range is here, if R is smaller than M1, then it is obviously smaller than M2 as well. So use this scenarios. If L is greater than M2, it is obviously greater than M1. What do we want? We want P. Then P is equal to L. Similarly, if R is smaller than M1, then P is equal to R. Initially, let P be M1 or M2, anything. Now, just iterate over the values like this and print that. This passes all our test case and is an accepted solution. Okay, so let's move to the next problem now. It is adjusting drones. So we are managing a fleet of n drones now with energy levels A1 to AN. Now we are given that any value cannot be greater than equal to k. That is, the frequency of any elements can never be strictly more than k times. If they are, then apply this operation on all of them. Alright, all of them. First, select all the drones whose energy appears earlier. That is, if we have 1 2 1 2 and our k value is 1, then the, let's say we had 1 2 1 2. Alright, and k is equal to 1. Then uh, 1 is appearing 2 times and 2 is appearing 2 times, which is a problem. So these two remove the, select the later values. That is, leaving the first values, select the later values. Even if it was 1 2 1 2 1 2, then select all these values, because this one has a appearance before, this 2 has a appearance before. Similarly for this one and this 2. Select them now and increment all of them by 1. Alright. Alright. Now do this process again unless and until no you this particular condition, that is all the frequencies should be strictly smaller than equal to k, should be satisfied. Here what are the highlighted values? 2 is highlighted, this 3 is not highlighted because it is the first occurrence. These 2 and 3 are highlighted, so this 2 is converted to 3, this 3 remain as it is, this 2 is converted to 3, and this 3 to 4. In the next step, this 3 are selected, then it is transformed to 4 4 and 4, and later on it is transformed to 5 5, and at the last step it is transformed to 4 5 6. All right, so this is the number of processes happening in each round. Now we are asked about the number of rounds this particular process will go on. All right, and see the constraint of AI. Constraint of AI is 2n. All right, so let's say what is the worst case of highest number that can be formed. Let's say we had 2 into n as the number and it appears n times. So what will be the, and k's value is equal to 1. Then our final array will look like this: 2n, 2n plus 1, 2n plus 2, and so on up till 3n minus 1. Alright, so the maximum possible value that can be gained is 3n, which is computable if we see the value of n. So try to think about something in that direction. Okay, let's move to some observations. What are the observations that we get? Let's say k value is 3 right now. Alright, now if we have 4 ones and the next value is 2, which appears one time, 3 is also appearing one time. So what is actually happening? Can these three ones be accommodated by 2? In the next step, they will be converted to 2's. But even again, it is exceeding k's value. So again, these two will be converted to 3's. Alright, again k is exceeding. So they can get converted to 4's. Alright, 3 4's. Unless and until they have an empty space. Alright, here a element was present which was 1, element was present, the next consecutive element was present which was 2, and similarly 3 was present, but 4 was not present. So this is how these ones, these extra ones would get accommodated later on. Okay, so we conclude values can get only accommodated in places which are missing. Alright, if x is missing, then any element smaller than x can get accommodated at that place. If another observation, let's say there were 5 ones. Alright, then what was the scenario? Then these 4 ones get transformed to 2, then 3, then 4. How many 4's are there? 4 4's are there, which is even now greater than 3. So what happens in next step? All these 4's move to 5. Alright. So another observation is a place can accommodate all the either k values or one value. Alright. If it is coming from behind. Alright. So this is it. These are the two important key observations in our question. Now what do we do? Just try to simulate this process. Okay, because this is a very simple process. Like if you try to write it in the form of code, all right, because if it can be accommodated, that is if we are having k extra values, accommodate it at current place, else do not accommodate and continue doing this. So let's try to simulate this process, and at the end the element, the maximum, or let's say the element that is shifted the maximum number of times gives us the answer. Okay, the number of times it is shifted, it is equal to the answer. All right, so let's move to the implementation now. So let's simulate the process. What do we have? We have the value of n and k. Then create a map of frequencies. Assign the frequencies now. Now create a prefix vector. What do this prefix vector tell? Prefix vector tells us what are the, this tells us count of elements that need to be resolved, or let's say count of elements present before, count as elements smaller than equal to I for each element I. Alright, how to create it? Just a normal prefix array. So create it. Prefix of I is equal to prefix of I minus 1 plus mp1 of I. Alright, now let's create a dp vector to simulate the process obviously. What do this DP state represent? Our state represent for element I, what is the maximum number of elements smaller than equal to I that can be resolved. What do resolved means? That they are fixed, they have got a place. All right, like this one got a place in index 5. All right, so what are the numbers smaller than equal to I that can be resolved, maximum number? All right, so how to do that? Let's simulate the process now. So what is the current number of let's say values or elements that needs to be resolved? It is equal to prefix of I, that is total number of elements that need to be resolved minus the number of elements that got resolved before itself. Now if the current value is smaller than equal to k, that is it can be accommodated, what we discussed earlier, then dp of I is equal to pref of I. All right, because all the elements got resolved. Otherwise, how much number of elements can be resolved at max? One. All right, if this element contains two elements even now, like this element contains, this two contains two twos. All right, then what happens? These three ones gets added here. All right, now there are five twos. Now even if that particular two was resolved in itself, then also these two needs to be transferred here in the next step. All right, that is why if the transfer happens, only one element will be remained. Now at the end, this process has been simulated. Now what is the maximum number of times this particular process is happening? All right, so for an element, if the transfer is started, then answer is equal to the number of times it takes to get that element resolved. All right, let's say for that example itself, so it is equal to, answer is equal to the maximum number of times a particular process has started and it keeps continuing, that is the transfer happens, the maximum number of times transfer happens. Let's say transfer started at 1 right now. Now it is, if it is resolved, answer is equal to maximum of the number of times transfer has happened, I minus prev, the element at which the transfer started to happen. All right, and right now, if since everything has been resolved, then P is equal to I plus 1, because this particular process is resolved right now. So next transfer might start from the next element. So P is equal to, or prev is equal to I minus 1. So let's compile the code. At the end, we just need to output answer value. So we have solved the fifth problem as well. All the best for upcoming contests. Thank you.